Hello, in this clip I will talk about the support managed Kubernetes service. In documents 1.3.0, we provide the ways to expand the storage size and upgrade the Kubernetes on different Kubernetes managed by the cloud providers. Though those documents are in version 1.3.0, they are not restricted to any of the Longhorn version. So those steps should also apply for different Longhorn version cluster. Let's look at AWS EKS. To expand the storage size on EKS is pretty straightforward because AWS EKS provides launch templates, which the users can directly modify and add in new volumes. For example, to access the launch template, I can go to EKS cluster and then resource, cluster node, and node group. In the node group, that will see a launch template. To modify the template, we go to Actions and Modify Template. And here, user need to put in the new template name. And then scroll down, the users can modify the existing store volume configurations for the existing template or adding new volume. When the instances are launched with the launch template, it will not automatically mount the device. If it's not automatically mount, the Longhorn will not see it. In that case, the user will need to copy this part of the user data script and then paste that into the user data under advanced detail. For the device path, it needs to match the new volume that we've added in. For example, that I've added a volume 2, and if I given a device name of device SDD, I will need to modify it to match. User might also want to change the mount path. This is the mount path of the mount path on the instance. So Longhorn will see this mount path and then attach that to a disk. Once the fields are filled in, the user can create a template version and roll that out to a existing cluster. Let's look at the AKS, Azure AKS. For Azure AKS, it doesn't support additional disk in the template. So what user need to do is that user need to create a new node pool. And with the Longhorn UI, the user need to disable the existing nodes disk and then call down and drain the Kubernetes of existing nodes. And once all the workloads have moved onto the new node pool, the user can then delete the old node pool. So in that way, user can have a new node pool with larger disk size. For Google Cloud Platform GKE, though it supports adding additional disk with local SSD count, but the local SSD has fixed size of 375 gigabytes. So anything beyond that, the user will need to create a new node pool, same as the Azure AKS. And once the node pool is created, user can disable the scheduling and then call down and drain. And once the workloads are moved over, delete the old node pool. Let's look at how to upgrade Kubernetes cluster in different platforms. For AWS EKS, the upgrade Kubernetes is pretty straightforward. We just need to follow the official document to upgrade the cluster. For Azure AKS, though it supports AKS upgrade the Kubernetes cluster, because when during the upgrades, the nodes will be re-imaged. That means the Longhorn will have a mounted attached disk, but the reimage instance will not have those devices. So in that way, we cannot upgrade direct with the official upgrade path. So for this case, the user will need to create a new node pool with a upgraded Kubernetes version. For example, if the user is using 1.21 Kubernetes version and the user wants to upgrade that to 1.24, the user will need to create a node pool with a Kubernetes version of the 1.24. And then with the new node pool, the user needs to go to Longhorn UI, disable this scheduling, and code on drain, then wait until all the workloads are moved over to a new node pool, and then delete the old node pool. For Google Cloud Platform GKE is straightforward. Just follow the official documents in your work. Thank you for listening.